Is it restarted? So, hey guys, welcome to High Entropy. So, it's day 99, just one day uh, far away, one day away from 100 days. But we are going to continue it further until I won't feel like, okay, I'm confident enough that I can solve most of the DSA problems. I mean, you cannot be sure that you can solve any problem, but at least you should get uh, enough confidence that you can solve at least most of the problems. So, right now, if you are watching for the first time, then let me tell you that actually my laptop is in this direction and I'm looking in this direction. So camera is in the side view. Okay, so let's begin without wasting time and let me just transition this. So right now I'm solving the graph problems and I'm right now just solving the problem on BFS and depth first search, breadth first search. I hope you can see my screen. Yes, you can see it. And okay, 1 minute. I just wanted to see if doc chat, if anyone is going to ping today, I will respond to you. Maybe because sometimes I feel like yesterday some people have commented and I was not able to respond to them. Just give me a second. I'll switch the screen. Just a second. Thank you. Why it is not copying? Complete sign in. Try another way. Use your passkey. Fuck Bancho. Why it's not working? Forward. Enter the integer code backup code. Oh fuck. It is asking for so many things. 6301243. Enter the code. Just give me a second. Cacto Pro. What the heck? Okay, so let me transition back and let's start. How can I dock it somewhere? Okay, leave it. Let's keep it aside. Oh god, I don't want to keep it somewhere. By the way, let me just open my how to keep it. Yeah, so let's jump to the graph and we are in the first. Okay, so word ladder we already solved this problem. It was an interesting one problem. I was not expecting like I need to solve it. I have to use some approach, but luckily I was able to solve it in one go. So wonderful. Solve word ladder 2. Word ladder. Sorry. Given two distinct words, start word, target word, and a list denoting word list of unique words of equal lengths. Find all shortest transformation sequence from start word to target word. You can return them in any order possible. So, okay, so we need to find and we need to return them. Okay. Hmm. Let me think about it. So we have words. Just one trick would be needed for it. When we are basically what we were doing in the last problem. Okay, so if you are watching it for the first time, then I will let you know exactly what needs to be done. So basically, we want to find out all the shortest transformation sequence. That means earlier we were just using max count, but that won't work. Now we need to find all shortest. A little tricky, but let's think more about it. So let me just note down the example first, so it will be easy for us to. Yes, definitely I need to practice it one more time because last time I was able to solve it, but I forget very quickly the solution whatever I'm writing. But I remember the concept. We have DES, DER, and TFR. Another one was DGT, and another one was DFS. So if you remember last time what we were doing, simply we were creating a graph. We have created a graph between these words, like where, for example, there is DES. So if you know DER, just we have changed one character, R and SR. So we created graph, and then DFR. If you notice, DFR is nothing but just change F to E to F or F to E. So DFR and DZT, and DZT is simply different one, DZT. And if you see D DFS. And also, one thing. So DJT is not correlating with any of these. So you can think of like this is another graph, and this is one graph. So components of graph you can think. Okay, another one. What I did simply we need to transition from DER to DFS, DER to DFS, DER to DFS. So why don't we add DER in the graph as well? So if you need no, okay, what I'll do. So here, this is DER. If you are changing, you can change from DES to DER. Wait a minute. Okay, DER is already in the list, so you don't need to add. Otherwise, you can simply add this word, start word as well in the list, and then you can create a graph, and then you can start from the this node, wherever it is, and try to reach to the target node. And one more, just check at starting. If the target node is not present in the graph, it means you cannot reach to it, right? Because it's not part of this word list. So how can you reach to this? And so, yeah, so this is the process. So right now what I was doing, simply I have started from start, and we need goal was target. So simply eh, what I did, simply I started from start, and I started traversing in the BF way, breadth first search, because we want to get into equidistance. So here and here I post all the neighbors of it, and just appended length. So for example, if there are two neighbors, for example here dr, for this if you are traversing dr to you can reach to des and equidistance. So I will push dr and then its neighbor in the queue, and then once you will traverse them, so it's like queue will be something like this. First will be dr, then you will once you will pop this dr from the queue, and you will include its neighbor. So des will be part of it, as well as dfr will be part of it, and its length from here. So here if you are adding 1, then here it will be 2, length plus 1, and here it will be 3. So that way you will keep on increasing the length, and then you will add this one once you will process these, and you are maintaining visited array that So what we were doing, so whenever you are reaching to target from a node, you are just comparing. So far if max count is greater than this, then you will just assign it new max count. But I have a doubt here. I know one approach would be simply first to calculate the max, correct, and then check for max. Wherever you are getting max, then you can run result, but it's very inefficient. So what else? Okay, so suppose what I'll do, first I will add der. So here just let's look at the graph. We have der, so in the queue there will be der, and then des, dfr, and then how will I store the result? That is the question. I don't want to. Okay, let's do one thing. So first thing, you will be having DER, correct? So this will be at index, let's say 0, length 0. So what I am thinking, why don't we do this in this way? So suppose here you are adding this, and then you are adding length 1, then here you are adding length 2, here you are adding length 2, here you are adding DFS length 3. So what I'll do, simply first I will add DER in the list, then it will be the, let's say it is at 0th index, then what you will add, you will add DES, and also you will add DFR here only, because both are at the same distance. Then at the third index, DFS, and then you will process DER, DES, DFS, DFR. Is it right approach? Still confusion. I have a confusion here. How to generate the result basically? It's extension of the previous problem, by the way. Let's think more clearly. So idea is simply we need to generate all the different paths. Some will be minimum, some will be maximum, and so we are not sure which one will be minimum. And here also we don't want to recompute everything. So definitely we have to follow one thing. One approach is first perform the DFS, BFS, and again you check whether the length is equal. I think that's inefficient. So so let me just walk through it one more time. Q will be something DES1, and another one will be, sorry, DER1, DES2, DFR2, and DFS3. And every time when you are pushing something, you are marking them as a visited, and when you are popping out, you will store it in such a way, DER, then you will store okay. Okay. One thing. So these all will be in the sequence for sure. DES, DES, DFR. If suppose there is another one, DFS, then it will be at 3, and it could be DFS 4, correct? So all the minimum will be at the same level. How we want the result? Okay. Fuck. It's wrong. No, it's not wrong. It's just hmm. How to do it, bro? Just thinking about it. I mean, just I will check if someone pinged me. I last time I did what I. No one pinged me. Great. Can I mix it in here? Yeah. Better. Okay. So let's do it. DRDR. Bro, how much time I just spent? I just wanted to check first. So it's 22 minutes. Fuck. I need to solve it quickly. So what I'll do, every time we are getting the result, that means it's extending. Earlier there was one option, now you have DES2 and there is another two. Earlier I was result like this at a starting. Now I got DES and DFR. So I will append DER and DES will be here, and suppose max length will be 2. If you are getting another one with max length 2 only, that means it should be something like DER, DES and DER. Why don't I do it like this? DER will be one item, DES will be one item, another you are appending at the same location, so it will be DFR, something like that. Oh, sorry. Oof, oof. Okay, I'm getting solution at least. And then what I'll do, I will process every time whatever the item that you are. Suppose there is another one, DPS, DPR, DKR. There are two or three. DKS. Let's example. Just I'm trying to formulate the solution. So it should be something like DER, DES, DK, and this one. How to do it, bro? approach is wrong. So it seems like. Is there any efficient way? Mm, mhm, mhm. I don't know. It feel like it's a headache when you will process solution. It will be like one length, two length, three length, four length. Let's say there are some items, there are some items, there are some items, and there are some items. Okay, now you want to process, and you got somewhere like you got a result here. This is the minimum result. So till here you will process because after that definitely those will be bigger number. Hmm? Where are you now? So what will be the approach here? Um, One, two, three, four. Huh. I just I'm wondering how to generate this solution at the end. Submissions never did. Editorial part one, part two. Crazy. In this problem, all the possible transformation from so must be found. Hence, in contrary to the previous problem, we do not stop the traversal on the first occurrence of end word, but rather continue it for as many occurrences of the word as possible, as we need all the shortest possible occurrences in word order to reach the word end. I don't want to watch the solution first. So what is the this is the problem with DSA. Sometimes you will feel like, oh, I don't have water. I'll keep. Hmm. So how to generate all possible solutions? It is like you will start with DER. Let's say now you got DES. So now it should be something like DER and DES and DER DFR. So let's see how to do it. It is like merging two arrays. Okay, one thing I know. We have this. So why don't we do one thing? For each item, you will create new result, and here what you will do. Link comment. What the will be like this? Then you will add item result dot extend previous result it will be very next time, but let's do it first. Let's do it while I dance. Okay, I forgot the solution, whatever I did yesterday. Step 1. Define a function. Define compare word. Why don't I copy solution from the previous one? Because I just want to check. Compare word 1, word 2, count equals to 0, you in range, this one, and here we need to check. It was lengthy solution, by the way. I created a adjacency list and everything was there. Max length. Instead of max length, what I'll do? Result will be something like this, and whatever you will do, result. So DQ, every time you are popping out one by one element, and whatever the length is there, so definitely all the same length elements will come at the same level. Node equals to target. So why don't I create one more variable? Target found equals to false, and whenever you are getting target found, simply what you will do, you will mark it true, and length will be uh, at starting it will be -1. We don't need max length here, simply target length. And whenever you are getting a node, so what you will do, if node equals to target, that means you got the target, and if it's not, I created this for a reason. Just I'm checking. So if L, if target found and L greater than target led, simply break because you already got, that means you won't get. Otherwise, what you will do, if it is not the case, then simply every time you will append it. If this is not the case, then that will to node equals to target font true, target length tell. And for neighbor, you will append the neighbors. Neighbors of it. Do you need to append neighbors of a node? Oh, it's a khichdi. I don't know. I feel like I just messed up somewhere. Something. भाई कोई देख रहा है क्या? Sorry भाई, I'm not looking. Hi bro. Solving this one. Word letter. Pinging you guys. Oh, Pooja. It's not pasting. Thanks. I don't know, I'm not able to paste it though. Okay, let me paste it here. No, sorry. I'll paste you. I'll paste question. I will not paste you. Okay, live stream. Solving this one, bro. Okay, let me paste it here. No, sorry. I'll paste you. I'll paste question. I will not paste you. Bye there. Live stream. I think I'm messing up. Somehow I'm not able to solve it. So I think I just watched video. I have one approach, but it feels like it's not the right approach. I'm uh, getting into wrong direction. So what I thought, I'll just tell you if anyone is gonna watch. Let me minimize it. Actually, I won't check. Oh, sorry, bro. This is not fair. Hey. So, where is my whiteboard? This is a, yeah. So I thought, why don't I, like, whenever I'm just maximize it. Whenever I'm visiting a node, I will just post it into the result array, and then I will. Okay, what I'll do, simply, let's solve it using this approach only. It's Herschel, bro. I'll clear everything. I will start from the beginning itself. Because. So first thing I remember, we have to use compare word, where I will compare the word. I make a lot of typo self and word 1, word 2. So I'm comparing the words, and if have the difference of 1, so length will be same. So I will just take length I'm just using the simple approach. I don't want to watch the tutorial first. First I wanted to try out, because if you'll watch tutorial I won't get anything. It's like you are watching and you'll forget it quickly. I forget, I don't know about you, but whenever I'm watching any tutorial, it's very easy to forget, because until you are not revising it twice, thrice, repeatedly. So I always prefer to try harder until you are not, until you don't feel like okay I won't be able to solve it. Then you can go to a approach, and if you want to optimize then definitely watch the tutorial. And I also prefer to watch the tutorial. For example, there I can see there are two patterns, so I will definitely watch the tutorial, but before that I want to try my best so that I can see if I can solve it. So let's, here what I will do, simply I'm comparing two words, and if length is count equals to 0, that means if the difference between two words, suppose here DER and DES, you can see DE both have same, D is same, E is same, and only R and S are unequal. So we can say okay, there is only one character difference between these two. So these can be transformation from this to DER to DES. So that's what I'm comparing, and I will build a adjacency list for it. So range n, and every time I'm going to compare. So if word, it's a simple word. I already did it, but I want to revise it. You can say word 2. Oh, not equals to. So then I'll increase the count plus equals to 1. And if whenever you are getting count greater than 1, that means there are more than one character difference between these two strings. So you can say okay, return false. That means it's not possible, they are not a single character transformation. Otherwise, simply if you are not able to get it, then return true. Okay, so this is one thing. Now second step is simply we got the compare word. We need to build the adjacency list, or you can say adjacency list for it. So before building the adjacency list, what needs to be done? I will check if the first word DER is not in the word list, then I will append it. Check if start, oh here they kept begin word, so no problem. If begin word is not in the word list, then append it. Okay, so I will do it. So how to check it? Okay, let's do one thing. EL in word list, just check if begin word. So I'm just using some dummy kind of code. I'm not focusing much on whether I'm using one loop, two loop, until it's nested. You can do it. Is available. I just available is to false. Oh no, sorry, it's misleading. Is exist false at a starting. If begin word equals to EL, that means it's already exists. So is exist, you can say equals to true, and you can break the loop. You don't need to perform it further. And if not is exist, if not exist, I think it's better if I'll use exist, right? Exist, it looks better when you are using if not exist. If not exist, simply we are going to do word list, oh sorry, dot append. We are going to append it, append exist. Oh sorry, it's not exist, it's a begin word, append. So we appended the word. And second thing is we need to find the source and target. Find the index of source. Let me tell you why I'm trying to find the index of source in this list. So I will assign every node, every word as a number. It will be easy for us to process instead of processing like okay, this is DES. So it will be easy to deal with numbers when we are building the adjacency list. For example, whenever you are dealing with the graph, it's easy. If you are processing with the 0 1 2 3, it's easy for you to uh, work on indexes instead of creating hash map and all. So earlier I was trying to do this, but I felt like okay, this is easy approach. So why don't I try this? So find index of source and target. Begin word. Okay, I will use the same word of begin word and end word. So I will call it start equals to -1, end equals to -1 for, and also you just do anything at a starting only. Primary check if end word. Oh, let's think about a corner case. No, it's like okay. End word not in word list. Word list. What does it mean? Simply return 0, bro. You cannot transform it. Sorry. Oh, typo mistake. Return 0. I'm not looking at chat, bro. If anyone is. Okay, no problem. Oh, shit. How to minimize it? No problem. So return 0. Otherwise, what I'll do, start and now I in range len of, or let's do n is nothing but len of word list. Word list. So we are going to check if okay, if word list of I equals to begin word, then start equals to, it's better if I'll use source target. So you will do one thing, source equals to I. If word list of I equals to end word, then target will be I. Finally, you got the source and target. Second thing, we need to build the adjacency list. So for each word, what you will do? For I in a range word. So you are going to compare like every word with another word like DES, all the pairs, and you will check okay, can we create an edge between these two words? So I in range and for Z in range and okay, sorry, I plus 1 to n. Z, I and J you are comparing. So okay, now what is word 1 is equals to word list of I, word 2 is equals to word list of J. So you are comparing these two words. If compare word list word 1 and word 2, right? 2 is not suggesting. Sorry, here I remember last time I got this self. It's a class method. Okay, so if both are like there is only one character difference between these two, this then this can be ages. And here what I'll do, adjacency adjacency list this, and here what I'll do, for each word there will be adjacency list. So you will say in range n you created, then so if word 1 equals to I, then there will be an as between I and j, correct? So adjacency list of I dot append j, and adjacency list of j dot append I. So I to j, j to I. So you build the adjacency list, and next step is you have to create queue to perform BFS operation. So from collections import deck DQUE. Is it lengthy, or am I making this? I'm just solving it using the lengthy approach. I just wanted to see how much code they have written it for it. How to compare line number of lines? It feels like they kept it simple compared to what I am writing. But okay, let's not think too much about the adjacency list. Got it. Okay, we created adjacency list. Now next step is calculate BFS. So dq equals to deck, and now dq dot append what? You will append first one, source I, no, source, and length will be 1. Okay, perfect. Now what you will do, I'm just worried about the solution. Okay, I will say while dq, while we have items in the dq. So first thing is node and dq, and length will be a dq dot pop left. Okay, you pop out item, and simply what you will do, so you okay, I forgot one thing. Visited array, bro. 0 into n, mark it visited, otherwise it will be, I forget lot of things in between. So that's why I prefer to solve it on whiteboard, but I don't know why nowadays I'm getting lazy. I equals to 1, sorry, visited of source equals to 1. That means this node is already being visited, and every time now you are going to pop item, you will check if, okay, I will just let me do one thing. So this is the tricky part, and after that building the solution. So so what I'll do, dq, no, not dq. If node equals to target, so if it is target node, that means you got the length. Okay, so what you'll do, simply just think, if you got the node, do you need to because you are performing at the same level, so do you need further its neighbor to be processed? No, right? So what you'll do, if node equals to target, simply do one thing. Okay. A result, I will create one result, and here I will keep like this. I will tell you what is the purpose for it. Better I will do one thing. I will keep like this, so it will be easy for us to process. And length 1. So you got the target. Node L, you got the node. Now you will check target. If it is matching with target, what does it mean? This definitely it will be the first one, minimum one. And if you are getting target, then first thing you will do, I will do uh, length. So min length will be -1, and at found target will be -1, false. So found target will be true, and min length will be L. So this is one, sorry, L. So you just controlling the flag. Now you don't need to uh, further basically append the node into the queue, at least for this node, its neighbor, if I'm not wrong. If something will be there, yeah, because 1 minute. Oh, Bancho. Sorry. Don't spoil my code. I think I'm. Oh, sorry. So yes, let's do. If it is not, then that means you will mark it as this, and you won't do anything, and just push the result dot. Okay, that means if len of I will do one thing. I'll keep like this. Len of result is less than L. Simply result dot append. I will tell you. So append. What you will do? You will do this, and you will add node into it. Else simply result of L -1 dot append node. No, not node. Yeah, node. This is one process. Else what you will do, simply if it is not the for NBR's neighbor in neighbors. No. Adjacency list of node, its neighbors you will get, and if not visited, NBR neighbor is not visited, then you will simply mark it visited neighbor and dq dot append node, not node, neighbor L+1. If my brain is working, then it should work. I just wanted to see the. Okay. Signals. Print result. I just want to see the result. I know. I definitely I will make some mistakes. What is result? Oh, what the heck, bro? I'm looking for a result. Where are two prints? One only. Return L. I'll just return. Let's say max length, not max, min length. Let's try. First min length should be this short. No, no, no. Oh, sorry. What I'll do? Print result, print min length, and return empty. It is just debugging. Before. Correct. For the two. Huh? Three. Ooh. Hmm. How much time? Oh god, 1 hour 8 minutes. Very bad. Oh, bracket, 4. Let me see. Adjacency list first. One four zero two 14. 102 and 44. 44. One thing I will do, if not found target, then only I add. If you already found the target, that means you already added this to the list, because the last one is causing the issue. So I got it. I'm doing some blended. Sorry. Flynn result lesson. I can solve it, but how? I don't know. I feel like I should drop this idea. Maybe I need to work more on this and let me watch the tutorial, because I already took almost 1 hour and it's better. Let's do one thing. Let's watch the tutorial.
So in the previous video, we did learn about word ladder one, where we had to convert the starting word to the target word using the given word list, and to do it in a minimum number of transformations. So word ladder two is an extension of the previous problem. So just in case you haven't checked out the previous problem, the link is in the description. Please make sure you check it out, because there's a pattern in which I have taught this particular code, and using that pattern only to solve this problem, word ladder two. So before starting this, I just want to give you a disclaimer that this is one of the toughest problems.
Still, my heart says I should solve it, because otherwise I have to watch his approach first. I know I'm near to the solution. Sorry. Let's do one thing. Let's hustle, bro. Hustle until you want. So let me try, because I solved most of the. Here, just I'm missing one thing. If it is last node, and if it is you already appended, you don't need to append it again. Uh, for other nodes, it's okay. Node equals to last target, and One. Oh, let me do one thing now. First, I should be getting the correct word. ZDK and GEK. Should be two only. I'm getting three. Okay, let's do one thing. Print result. Instead of printing result, I will do one thing. Now let's process the result. For okay, for each for uh, item and then for each node. So result is something like here. Result will be fin result like this, and now you will get nodes. So what you will do? Oh, it's a very computing process, tedious process, but let's do. So node in nodes, basically for each node you need to append into the existing result. So I mean whatever the result you have. Every node you will append for uh, temporary result in fin result. So each item you are checking and what exactly you are doing. So no, or I mean it's very bad, disastrous way to process. Why don't I ask Chat GPT give me result? One 0 to 4. Three character 1 0 4 1 2 4. Okay, let's do that. Whatever is coming into my mind. Final result I have. So every time what I'm doing, updating. I think I should ask Chat. Simplest approach to convert a list like this to. I'll just go to here. I have a list and want to change it to it's like 1 0 4 and 1 0 1 2 4. Is it supporting IT tools? Let's see. Why would I do a lot of computation unnecessary? Just let me check if it is working. But I think I left some code that is unnecessarily. Oh, let's do. Excited for it. It's like you are what exactly you am doing. Result list. And what is data? Data is my result. Result, bro. Result. Written result. Print result. Hustle. Stupid hustle. 104 124. Now I will do this manually. Change each item to string for new result. NR. I will just make it like this. Okay, let's do one thing. Can I change these value to another values by looking into a list and their values? Oh bro, I don't want that. So result new is equals to for result in result. So every time you will get list, and for each list what you will do, you are going to say okay, we have something word list. Of I for I in result. Look at DR, DS, DFS, DR, DFRD, FS. Fuck. What the heck? Huh? From where it is getting this? It is working for this one, but it failed for this one. Vibro two times. Some mistakes. Mistaken. Not mistaken. Mistakes. I think I should watch the tutorial. Man. Give me 1 minute. I will fill my bottle. No. I will do one thing. I will take break. I mean, not break. I'm back. Okay. How much time? Oh wait, 1 hour 30 minutes to just to solve this, and still Fuddu. I'm not able to. GDKG. Crazy. We found target is already there, and L plus 1 is less than mean length. भाई हो गया इसका कांड. It's not going to work. Let's watch a tutorial.
the views. So the end of the video just gives you have this vibe that how will I think about such solutions? Do not worry, do not worry. These problems are something which you have to practice so that if something similar comes up in an interview, you can answer. Okay, this will never come by yourself. Anyways, so what ladder 2 all about? So it's the same problem. You will be given a start word and you'll be given a target word, and you need to convert the start word to the target word, and the transformations are only allowed in this particular word list. But over here, instead of printing like in the word ladder word, you have to print the sequence, the length of the sequence. Over here, you have to print all the possible shortest sequences. So if I go back to the iPad, imagine the beginning word is back and the end word is cause. Okay, so and these are the word list. Suddenly, these are a couple of these. Back can be transformed to pad, back to pot to pause, and then cause. And similarly, back can be transferred to pot to pot to pause to cause. This portion is similar, but if you see the first transformation is different. The first transformation is different. So this is also taking like 5 sequence length. This is also taking like 5 sequence length. Since both of these are taking 5 sequence length, and that is the shortest we can do. So you need to return me this, and then you need to return me this one as well. And also you can return the list in any possible order, like this can be first or this can be first, doesn't matter. What matters is you need to return both of them. Any order doesn't matter. So how do you do this? Because if you go back to the previous word ladder 1 problem, it's very straightforward. You started with the word, you kept this length, and you kept on trying to change from A to Z for every alphabet, and you ended up at clock. Will that method work over here? No, that method is not going to work. Why? Because they need to tell me the sequence. So this time, the algorithm will be slightly different. Yes, it won't be a straightforward BFS. Instead of a straightforward BFS, we have to do some observations. Yes, we have to do some observations. And while doing it, I'll be telling you about the observation. So before doing the observation, first observation that I want you to have a look is first level, second level, third level, fourth level, fifth level. So the level always increases in this order in the BFS steps. If you know, if you're doing steps, you always go level 1, then you go level 2, 22 level 2s, and level 3s, then level 4s. And that is what the BFS traps is all about. And that is where the gist of the solution lies. Okay, let's get started. So what did we usually do? In order to run a BFS traversal, the first thing we did was we always took a queue data structure. Please take a queue data structure. But this time, the queue data structure will not be this big. It will take a one. Yes. Why? I'll tell you. Because we're going to store the sequence. We're going to store the sequence. So the sequence starts with bat for sure. So do one thing. Just store bat. Do not do anything. Just store bat in a list and put that into the queue. So your queue will be storing list. Okay. So let's start the BFS. So when the BFS call starts, you give the list with bat. So can I see if the sequence is bat? Can I see the word is bat itself? Because if you are having a sequence, the last word of that sequence is the word that you need to convert into. So from bat, where can you go? From bat, you can change this B and you can make something as bat. You can change this B and you can make something as bat for sure. Do you erase bat? Now over here, very, very important. You do not erase anything right now. You do not erase anything right now. Why? I'll tell you when we move forward. Do not erase the bat from you. Keep it. Next, can you change it to something else? I think you can change it to bot as well. If you carefully see, if I change A to O, that will be bot. Bot is here. Pat is here. So what I did is I took bat and I changed it to pat and bot. So bat can be changed to pat. So if a bat is changed to pat, can I see the new sequence will be bat comma pat for this one. I am changing bat to bot. The new sequence will be bat comma bot. Can I see this? Because bat is transformed to pat, so pat gets attached, so you get bat and pat. Pat gets transformed to bot, so bot gets attached, so you get pat and bot. Yeah. So the sequences are done of length 2. Now comes the trick. So you use something like a pat. You used something like a bot. Once you have done everything in that level, once you have taken all the possible transformations in that level, take the pattern back and delete. Then only delete. Why not when you delete? I'll tell you, do not worry about that. Done? So this is one of the levels done. Next, take back pat out. Take back pat out. Now remember one thing, when I say level 1 only consists of this. When I say level 2, Level 2 consisted of these two things. Level 2 consisted of these two things. There are two guys at the level 2. There are two guys in the level 2. So you're going to deal with both of these two guys and then you're going to deal. And now you'll understand why. So, can I see if the sequence is this? The last guy is Pat for sure. So I get the last guy. And this is where we'll start the transformation part. So Pat can actually be converted to something like pot. Why? Because we clearly see Pat can be converted to pot because pot is there. Can I convert Pat to something else? I don't think. You can try converting Pat to something else. Maybe something like Pat could have been converted to Bat, but it's actually going back. It's actually going back to not pot, and it is not in the world list as well. So Pat can only be converted to pot. Will you erase pot? You could have erased pot because this level is done. This is level 3. Level 3 is done because you got bat, pot. You got bat, pot. You could erase it. But I said the entire level has to be completed. The entire level 2 has to be completed. You just completed bat. There's someone else of level 2 already waiting. So do not erase pot from here. Do not erase pot from here. Why? You'll understand now. So bat, pot is done. Okay. Get the next guy. Bat, bot. So which is the last word? Bot. So take the bot. Now in bot, if you do a transformation, you can actually get pot again. And imagine, while forming this, if you would have deleted pot, you would have never got pot back again. So the same level, pot can happen multiple times. So if you look at the answer, pot happens here, pot happens here. So once you form this, you get pot. And similarly from bot also when you get pot. So do not delete. Yes, beyond this, do not take pot. Do not take because of the reason that the length will delete the shortest length. So if you get a pot at a level, take it as many times as you're getting. After this, do not take because the length will be not the shortest one there. But thereby, again you get a pot. But this is what you do is you say bat, bot, pot. And now, since I can see all the level 2 guys are completed, now I can clearly state that is all the level 2 guys are completed. So what I will do is, I will simply now erase the pot because pot has been used in this particular level as many times as I wanted. Perfect case. Next, this is level 3. So there are 2 guys in the queue. So you can iterate for 2 times, pick once this. So I iterate for 2 times, pick up the next 2 elements because you know the next 2 elements are level 3. Because you know the next 3 elements are level 3. So just go ahead and do that. First thing is bat, pot. So can I see what is pot? I can. You can again try transforming pot into all of these like AOT, BOT, then you can go for O like PAD, PBD, PCT, then you can go for T, you can make it POA, POB, POC, and so on. So
this is more in if
you'll actually get POZ. Because P can be converted to Z and you get POZ. The moment you get POZ, you see POZ is here.
God, I need to watch the tutorial, but not now. I will mash up what's wrong in my solution. Let's see this option. ZK. So we will add GEAK, ZEFK, ZEDK. So these are the word list. Now what we'll do, so you can say ZEEK, to you can go ZEFK and ZEDK. What about ZEDK? GEF. GEDK. So we want to go to start word GDK. So ZDK to ZEK. Simply when I'm pushing the node equals to target and not found. Here is the issue. If not no no no. If not node equals to target. Hmm. I feel okay. Let's do one thing. Node equals to not node equals to target. So that is okay. And another condition should be if the node is not equals to target and not found target, I can optimize it. I mean, not optimize, but to be honest. So when you are processing at each level, there will be result. Result will be lying at a particular level. So whenever you are processing those nodes, here you added GFK, ZEK, both are at the same level. So you will say found target. Then you will check if found target. We just can append only uh, hustling in a problem. If we have target, we found the target, then what needs to be done? Simply if found target, then else. There are two scenarios. If target is already found, so simply dot append and node. So this is one condition. If not found target, so if we'll check if node equals to target, simply what you'll do, that means you found target is to true, and min max equals to L. If it is not the case, what does it mean? We haven't found the target yet, and that means simply, sorry, I need to do one thing. Result of append node. We need to append it. Okay, if it is not found, so if target is not found yet, so this is one of the problem where I'm hustling lot. Imagine if I will be able to solve the confidence level that. You don't need to check this. God, help me. Oh God, God. Blank 4. Am I taking a lot of time, bro? I will just skip this problem. I think. Oh, let me write a note. Banchot. Not able to solve. Sorry, not able to solve. Okay, I'll mark it star asterisk. No, no, no. It's not this. Number of island. Let's jump into another problem. Actually, I will. I have to solve multiple problems. No problem. Problem is a problem. Let me drink water. I will try to solve this. Because I know if I will come every day and I will solve one or problem or I am hustling. Hustling is not the solution, bro. Ultimately, goal is to grind. Given a grid of size and cross M, n is the number of rows and m is the number of columns in the grid. N is number of rows, m is the number of column. Okay, consisting of zeros, water, one land. Find the number of island. An island is surrounded by water. Zeros, water, one is land. Okay. So it is like you have to just check. Why two? I feel like three. An island is surrounded by water and is formed by connecting odd eight direct. So sorry. I just said eight odd direction. It is like this one will be one. This is two. Looks simple. It seems like approachable problem compared to the previous one, but previous one is an interesting problem to be honest. 3 to 5. 4. 1 1 1 1 0 1 1 0 0 0 0 0 1 1 1 1 0 0 0. Okay, so this is a problem. Here we need to find all the island. So if you see, island can be surrounded by zeros. So this is one of the island. Color, very bad selection of color. This one is a one island. Here you can see all are connected, and it's like okay, this is one where everything is connected, and you know one thing, this is one island, and another one is this one. Yes, these are the two islands. So you have four. How many options from a node? You can go in eight direction. So okay, that's why I was confused. Like we are just going to go up and down, but here we have four eight options. So that's why here, if you are here, so one thing I'll just that is coming into my mind. Isn't it a simple problem? Look simple to me. I don't know about you. So why don't we perform visit like a just look for a node and just perform the depth first search or BFS. You can perform anything and just traverse from it. So you will be able to, suppose you are here, you pick any random node. I mean all the node vertices from here, and you will just go here. You will be able to visit here, and also you will be able to visit here, then here, and in another one, what you will do, you will be so it is like one part you are applying DFS on this here, here. This one all you will be able to visit from here, and every time when you are visiting, you are just making count of it. Bro, it's simple approach, I believe. So what we'll do, we'll maintain. So steps I will write down just, then we'll solve it directly. Step 1, make a visited array. Okay, and yeah, so visited array, and here you will just everything, you will mark everything, these array. Okay, so one thing, just do mark our, and step 2, mark all water cells as visited, and now you start iterating from all the items from each. For step 3, just do one thing: you mark them visited like all these cells, so you won't be able to reach them. Now whatever the one cell are there, so you will just start iterating to each cell, iterate over each cell. If not visited, it is simple problem, bro. So call, just I'm calling DFS on that cell. So DFS will do what it will do. It will mark, or it will just visit all the nodes, all the connected nodes. Basically, it's a graph. This is one graph, and all it will mark. What it will do? It will mark everything visited. And whenever you are visiting none, just count plus equals to 1. That means this is a new graph. These are different graph components, you can say. So let's do it. This is not a new problem, by the way, until I'm not underestimating it. I do not believe. Okay, so let's do one thing. M MBA. So and let's create a M rows len of grid. And I forget about these numbers. They are not providing, so we'll create according to us. Here they are calling n rows, m columns. I'm just calling it n rows, and here len of grid of 0 will be columns. Just I'm not flexing, but for I in range. No. Visited equals to 0 into n for underscore in range m. So basically we created visited array, everything is marked as, and now will I in range n, sorry, m rows for j in range n. If grid of ij equals to 0, just visited of I and j equals to 1. Another thing, this is one step, and I will copy this same. Perform DFS. Perform DFS and count equals to 0. I and j. If not visited I and j, that means you can call DFS on self.dfs. Self.dfs I and j. Okay, wonderful. Also, don't forget, visited we need to pass. How would it know? And another thing, count plus equals to 1 pass. Define DFS self I j visited. Okay, if not, so let me do one thing. Simply it's not visited, bro, so you do not. So mark visited of I and j equals to 1, and moves will be 8 moves. God, I need to jot down all the moves. So first thing, I forget. Let's write down all the moves. They are these directions. So it will be like your I will be 0 and 1, 0 minus 1, 1, 0 minus 1, 0, minus 1, 1, and 1 comma 1, 1 comma minus 1, and it will be like something. Can I copy it? So first thing, 0 comma minus 1, another move will be 0 comma 1, x-axis, and y-axis minus 1, 0, and 1 and 0. These are the moves. Now diagonal moves, you can say minus 1 minus 1. Okay, 1 comma minus 1, minus 1 comma 1, 1 comma 1. So these are the moves. So for move in moves, it's better if I'll use m and n also. I don't need to compute. So x will be, I am using heavily x, I plus move of 0, y is equals to j plus move of 1. Now if x less than m, x greater than equals to 0, and x less than m, and y greater than equals to 0, and y less than equals to no, n, then simply it's a valid move, so you will do it. And not visited of x and y, visited of x y is equals to 1 and so you will mark it visited, and you will call DFS, bro, just self dot DFS of x and y visited mn. Perfect. So and at the end it will call recursively, and it will visit all the nodes, and here you will get the count. It is, I am telling, it's very simple problem. If you it's a basic the problem I believe that we started with. What's wrong? Overconfidence, bro. Not here. Oh, it's not impacting. Let me see if moves are correct one. 0, 1 and 0 minus 1, 0, 1, 0, 0 minus 1, 0, 1, minus 1, 0 and 1, 0. 1 comma 0 minus 1 comma 0, here 0 comma 1, 0. There is issue some. Print visited. Oh, typo. 0, 0, 0. Ooh. Why the visited is still everything 0, 0, 0, not visited even after performing this? Is it a string array? Hmm. This was a very simple problem, bro. It's revision, just revision, just revision. No, no revision. La la la. And it's well. Let me check if anyone is watching. So sorry if you watching. Oh, guys. Amulu, Amulu. Who is Amulu? I don't know. Sorts. Fuck. Who is Umlu? Hey bro, sorry if you are watching. Bro, when you said, hello dude, I'm here, backtracking most probably. Either do, either go for the BFS or DFS or BFS. Sorry bro, I was not looking into the chat. What the heck? Where? Rem- this is not my. Can do with both approach. Approach. Okay, let's do one thing. Approach. Sorry. Okay, let's do one thing. Actually, I was not looking into the chat, bro. That's the problem. Let's jump into another problem. Sorry. Bro, भाई अभी बहुत सारे करने हैं questions. Until you won't get enough confidence. Until I won't get, irrespective whether I'm waking up till 4 a.m., 6 a.m. I'm waking. I'm staying up till 4, 5, 6. I'm waking up later only. So no, let's practice more. Hard. It will break my heart. Let's see. I will take 5 minutes break. I will scroll reels. You can listen music. Because I'm just cannot do continuously. You kept which screen you can see right now. Oh God. I will scroll some reels first. It's very important. Friends, Genji made the Government fault. GOA fault. What is it? Speak with me. Yeah, let's just speak. Where's my favorite reel? Shorts. I've watched it so many times. This one, I'll tell you. The CGP protest reels. Hey, I'm thinking like I will stop watch. I should stop watching these reels, shorts, whatever you say. It's time killing. No, this is not the one.
अगर 5 रुपए की
You know one thing, music can change the tone of video, or you can say the purpose of video. You can add any sad music or music that is completely different, sends different meaning. Here also, it's completely funny when it starts with. Now it seems like, oh, he is so sensible. But this one is not my favorite one. Where is my favorite one? Bro, this girl. It's real. Shorts. Popular, popular, popular. No, it's not popular one. Popular. Popular, popular. What the heck, bro? Where is that one? Let us. This one.
सी प्यासी मर जाऊंगी ऐसे मुझे ऐसे तड़पाना
I have watched this reel so many times.
मिला मिला नजर से नजर आजा तुझे है रंग दिखाऊंगी
I'll be back.
सी प्यासी मर जाऊंगी ऐसे मुझे ऐसे तड़पाना
Just 1 minute.
जरा भी मिला मिला नजर से नजर आजा तुझे है रंग दिखाऊंगी I don't know what to do. I don't know what to do. आगे क्या करूं? सी प्यासी मर जाऊंगी ऐसे मुझे ऐसे तड़पाना ना कर जरा भी फिक्र मिला मिला नजर से नजर आजा तुझे है रंग दिखाऊंगी I don't know what to do. I don't know what to do. आगे क्या करूं? सी प्यासी मर जाऊंगी ऐसे मुझे ऐसे तड़पाना ना कर जरा भी फिक्र मिला मिला नजर से नजर आजा तुझे है रंग दिखाऊंगी I don't know what to do. I don't know what to do. आगे क्या करूं? सी प्यासी मर जाऊंगी ऐसे मुझे ऐसे तड़पाना ना कर जरा भी फिक्र मिला मिला
I hope you can see my underwear is hanging there. So stay here.
I don't know what to do. I don't know what to do.
That's enough. Oh, I can see my screen.
I went to my school after 7 years और जान
I
के
went to
क्यों
my
join हो?
school after 7 years, so what should we do? What was?
हाथ से बने हिंदू, माँ से बने मुसलमान। हाथ से बने हिंदू, माँ से बने मुसलमान। और हाँ और माँ को मिला दो तो हम बने, और हमसे बने हिंदुस्तान। हम क्या बनाने आए थे, हम क्या बना बैठे। हम क्या बनाने आए थे, हम क्या बना बैठे। हम मंदिर बना बैठे, हम मस्जिद बना बैठे। हमसे तो एक जात अच्छी है परिंदे की। हमसे तो एक जात अच्छी है परिंदे की। कभी मंदिर में जा बैठे, कभी मस्जिद में जा बैठे। अब यहाँ सुनिए, अभी और सुनिए। हाँ, मंदिर मस्जिद गिरजाघर ने बांट लिया भगवान को। धरती बांटी सागर बांटा, मत बांटो इंसान को, मत बांटो इंसान को। अब हाथ से बने हिंदू, माँ से बने मुसलमान। तो दोस्तों अभी हमारे घर में पंडित जी।
Bro, let's study, else I will keep scrolling reels only. Short motivation. I got short motivation, and it will end very quickly once I'll trap into a problem. Okay, Bi bipartite graph. What is it? I just want to know the meaning of it. Bipartite meaning made up of or involving two separate parts. दो खंडों वाला द्विखंडी. What the fuck? I didn't get. Made up of involving two separate parts. Oh, let's see. Bipartite given an undirected graph with v vertices labeled from 0 to v minus 1. Okay, so far everything is good. Undirected graph, that means edges will be between a and b and a. The graph is represented using 2D vectors edges, where edges of I represents the and 1 minute. So, given another graph, vertices labeled from 0 to v minus 1, the graph is represented. Let's do one thing. I will keep 45 minutes timer and let's recreate about it. So given an entire of 0 to v minus 1, the graph is represented using 2D vector edges. 2D vector edges. 2D vector edges where edge of I represents an undirected wait a minute. Given under graph is represented using 2D vector, 2D two-dimensional vector edges where edge of edge of I represents edge of ith represents I0 to I1. Okay, it's the input method. Determine if the graph is bipartite or not. A graph is bipartite if the nodes can be partitioned into two independent sets A and B, such that every edge in the graph connects to nodes in set A and zero to 1 3. A graph is bipartite if the nodes can be partitioned into two independent sets A and B such that every edge in the graph connects the nodes can be partitioned into two independent sets. Okay. So zero connects to 1 and 0 connects to 3, 0 connects to 1 and 3 and 2 connects to 1 and 3. So basically all the nodes in set A are connecting to all the nodes in set B, and okay, V 0 1 0 2 0 3 2 1 3 2. Let me draw. 0 1 and 3 2. This is one of the option. So here if it's notice one thing, let me minimize it. These all unnecessary stuff. Okay, so what exactly it is saying? So you have given a graph and now you just need to split it into two parts. Split it into two set of nodes. Let's say this is one set, this is one set, so that all the nodes, let's say there are AB and CD E, let's say, so every node of this is able to reach to these nodes. So it should be something like A to C you can reach, A to D you can reach, A to E you can reach, and B to C you can reach, B to D you can reach, B to E you can reach. So can I get something like don't it has some relation between A and B because of it. It is like you need to find out all the vertices pointing to the same set of adjacency item. So for example here you will say for A it will be C D E, for B it will be C D E. Oh, and for C it will be A and B, and for D it will be A and B, for E it will be so that's why this is one set, this is one set. I'm thinking a smart approach for it. Don't you think like okay, just we need to find out all the different values here. For example, here you can say just forget about these values. Just look at this. This is one value. This is one value. Same value. This is another one value. This is another one. I mean, yeah. So you can say one pointing to one, pointing to two, pointing to two, pointing to two. Is that so simple? Or I am confused. Confused. Hmm. No, I'm not. Let's do one thing. Why this is dark? Okay, let's do one thing. First, 0, another example, 0 to 1 and 0 to 2 and 0 to 3 and 2 to 1, 3 to 2, 2 to 1, 3 to 2. Now just build adjacency for it. Okay, let's build adjacency for it. For 0, neighbors are 1 and 2 and 3. For 1, neighbors are 0 and 2. For 2, neighbors are 0 and 3. And for 3, neighbors are 0 and 2. And now see how many different pairs are there. So this is 1, this is 1, 0 and 3 is 2, this is 3. I'm confused. Is it so simple or I'm just thinking in wrong way? Sometimes it feels like okay, you are going in the wrong direction maybe. And here what I'll do. Okay, but let's think. So these are the adjacency list. How will I count different distinct adjacency list? Let's think about it. Let's think first what is the time number of phases can be between, so number of vertices and edges can be 1 to 10 to the power 4. One and 10 to the power 4. So suppose now you will create adjacency list for each. So maximum element in a so number of adjacency items can be 10 to the power 4, and for each it could be 10 to the power 4. So what exactly you will do? You will start checking this, and then you will make another unique pair. What I'll do, I will keep them in sorted, and I will just check if it is already in this. By the way, yeah, let's imagine this is we are going to compare this. Suppose 1 2 3 is there, and now you are comparing again 1 2 3. So what will be the time taken process? 10 to the power 4 different ages, and for each you are going to perform. So for a particular, it can go up to 10 to the power 4 number of items. So it will be 10 to the power 4 into 10 to the power 4, 10 to the power 8. No, wouldn't there be option easy? Hmm. Think, bro. This is not the right approach, I feel. I was so happy. I thought it's very easy one, but here time complexity will increase. It will kill the problem. You got it? Okay. From 0 you can visit 1. You can visit 3. So you will be so happy. Let's do one thing. Just think. Zero, you will be able to visit 1, 2, 3. 0, 1, 2, 3. Hmm. How to think in BFS terms? BFS or DFS? We need to find if we can break into, if we can. There will be some hidden property. 0, 1, 2, 3. It is like a cycle. Is there any other way? Let's say 0, 1, 2, 3, 4. Rest depends on ABC, ABC depends on. It is like A, B, and B, A. This kind of relation. My phone turned off, bro. Sit. It's charged. Just give me a few seconds. I'll keep it as it. Okay, let's do anything. I don't know how to do it. A connected to, let's say, directive graph. What is this? There will be some hidden property. I don't know how to get it. All the nodes having relation for each node be having the relationship. BCD. D is having BC. E is having BC. A B C D E. For B it will be D. For B it will be E A. And for C A D C A D. I'm just trying to find the pattern just by creating adjacency list. For E, no, for C it will be C A D A D and E. And for D B C B C already E B C. So sorry, actually I forgot to turn on the camera. FaceTime camera. Sit. It's not looking good. Let me see if it is working. I like side view. Crazy. No man, I cannot use. Another thing is here the camera quality is good. That is very bad. I don't want to look ugly. Seems like not working, bro. 45 minutes now. I don't want to spend more time on it because I'm not getting. Let me see the hints first. A B C A B C. No. Use BFS to color nodes alternatively, like a checkerboard pattern. If a node is already colored with the same color as its adjacent node, the graph is not bipartite. God. A B C. Something should be here, something should be here, something should be here. No, this one won't be possible. I'm not getting any property. I think I need to. I don't have any option.
So in this video, we're going to learn about bipartite graph, and we're going to solve this using the BFS technique. So if you haven't watched the BFS video, go back and watch it out. So what is the definition of bipartite graph? It states if you can color the graph with two colors such that no adjacent nodes have same color. Like you are given a graph and you can take any two colors, black and white, yellow and green, any two colors in the world. And if you are able to color it with those two colors such that none of the adjacent nodes, or you can call them as neighbor nodes, have the same color. So for example, if you see this particular graph, you see this, right? So let's take the color yellow and green and let's try to color it. So imagine I give this a color yellow. Definitely this is the adjacent node. I cannot color it with yellow color because the condition clearly states no two adjacent nodes have the same color. So I have to color this with green. So this is the next adjacent. I cannot color it with green. I have to color it with yellow. So I'll color that with yellow, and similarly green, yellow, green, yellow, green. And over here it will be yellow because the previous one was green. So this cannot be green. So this will be a yellow and this will be a green. And if you see for this particular graph, I was able to color this particular graph with just two colors. Do you see that? Yes, I took two colors and I was able to color this graph with two colors. So thereby I can say that this graph is nothing but a bipartite graph. Yes, this graph can be called as a bipartite graph. Now let's look at the next example. Now if you see this example and I again take the same color, yellow and green, and I try to color, this will be yellow, this cannot be yellow, so it will be green, the next one cannot be green, so it will be yellow, then it will be green, then it will be yellow, then it will be green. So if you go over here, this is green, so this cannot be green, so this will be yellow. Now the moment you try to color this with green, because you cannot color it with yellow because this was yellow, so you have to color it with the other color, which is green. But if you try to color it with the other color green, you see that the next adjacent node also has a green, so you need to color it with yellow. But wait, this is having a yellow color. So you are somewhere in between where one of your adjacent nodes has a green, one of your adjacent nodes has a yellow. Thereby you cannot color it with any of the colors because the moment you color, any of the two nodes will have the same color. Thereby you can say this graph is not a bipartite graph. I hope that makes sense. Something to observe very deeply. We can always color a graph which is a linear graph. Imagine you're given a graph like this, linear graphs. Now these are called linear graphs which will never have a cycle. So you can always take two colors. Since they do not have a cycle, you can just go on coloring them. So linear graphs with no cycles are always bipartite. Remember this. They're always bipartite graph. Now what is the next step? The next step is but this is a graph of the cycle. But the cycle.
Wait a minute. How can it be bipartite? Let's say 0 is connected to 1, 1 is connected to 2, 2 is connected to 3. Can be said it is bipartite. 0 having 1 is having 0 and 2 and 2 is having 1 and 3 is having 2 only, but this is not a bipartite as per this question. But let's watch.
Length. Let's count the cycle. The cycle length is 1, 2, 3, 4, 5, 6. So any graph with an even cycle length can also be bipartite. Very, very important. Any graph with an even cycle length. Any graph with an even cycle length can also be bipartite. So I can say that any graph with an even cycle length can also be bipartite. So which graphs cannot be bipartite? Yes, any graph with a length of odd. If you count the length 1, 2, 3, 4, 5. Any graph which has an odd length cycle can never be a bipartite. Any graph with odd length cycle can never be a bipartite. So if you're checking for bipartiteness and the graph is not a bipartite graph, then you can see that the graph has an odd length cycle, thereby it is a non-bipartite graph. I hope the definition of bipartite is clear to you. So we're going to check for bipartiteness using the BFS algorithm. Now you know what are the requirements of the BFS algorithm? It requires a cumulative structure. It requires a visited array, but instead of visited, we will take a color array where we have all the 8 nodes and everything is non-colored. And -1 means not colored yet. Yes, -1 means not colored yet. And what we will try to do is we will try to color it with color 0 or color 1. You can take any other colors as well, but I'll try to color it with color 0 and color 1. These are my two.
This is different, bro. Here it is asking simply split it into two parts, two halves. 45 minutes. Is it? Hmm. Graph meaning. Why don't you divide the total vertices into two distinct? God. How it fits into this problem? Hey, stop it. Zero, three, 5. 035. No, they are not connected. But 0 is not connected to 4. Let's say We have 5 nodes. Zero to one, one to two, two to three, three to four, four to five. The graph reverts is labeled from 0 to v minus 1. The graph is represented into two independent set A and B such that, so I'm just misunderstood the problem. In set A should be connect to every if they have no connection at all. Single applicants applies to every single job on the market. I think I will take a break better. Sorry. Let me stop